Okay, welcome to lecture 14. So we are at the end of the 7th week of the semester, which is the mid of the semester. So today we will continue with our discussion on language modeling. In the previous lecture, we had talked about the n-gram language modeling approach. So today we will move on to large language models. Large language models are primarily based on neural networks. We also call them neuro language models. In the older days, nowadays they are primarily known as large language models. So, so that would be the agenda for today. Much of today's discussion would be kind of a discussion with use of slides. Uh, so there wouldn't be too much math or other uh, details, but of course it will be discussion based on slides. So we need to clarify some concepts related to large language models. So in the upcoming lectures, maybe starting from next lecture, we will talk about the recurrent neural network model and the transformer model. So let's get started. Are there any questions? So large language models, so that is the primary agenda for today. So all of you are familiar with large language models and all of you also use them almost on your daily basis. And as I said in the previous lecture, we had talked about language models, specifically the probabilistic approach to language modeling, which is also known as the n-gram language modeling. So today we will start with that and then discuss some various concepts that are relevant to LLMs. Along the way, we'll also discuss how a feed-forward neural network can be a language model, a neural language model. So we'll discuss that as well. So are there any questions before I move on and get started? So I will use these slides from the book for some of the discussion, and wherever we need clarification, we'll go to the notes. So you can think of a large language model as a computational agent, and that's how most of you use it today. So it's a computational agent that you interact with, meaning that you send text to it, and based on that text, it gives back feedback as text. Okay? And in that interaction, it can do a lot of things. And as we will see, this interaction as well as the generation that is done by a large language model can solve almost all NLP tasks. Of course, some it does better than others, but you can solve even classification problems using an LLM. You can solve, let's say, tagging problems using LLM, even though it may not be the best. But of course, it does a very good job at summarization, a very good job at translation, and so on. So those are generation problems, which are naturally suited to large language models. Okay. So primarily, a language model assigns a probability to the next word given a context. Okay. Or it gives the probability of a word given the context that may be not just before it, it may also include context after it. So there are different shades of language model, but mostly it is a context that precedes a given word. Okay? So that's the idea of a language model, which we saw in probabilistic language model as well. And the context, of course, can be small and large depending on your capacity. And given that input context, it generates the next word based on a distribution and sampling over that distribution. And such language models are usually trained on lots of text, meaning that each and everything that you can find that's written in text. So a large language model, the only difference between a regular language model and a large language model is number one is they are usually based on neural networks. So far we have talked about probabilistic language models. Large language models are based on neural networks. That's one thing. And of course, they are trained on large amounts of data. As I said before, books and the web page and dialogue and conversations, uh, articles, research papers, even things that have been written in the past, let's say 200 years back, would already be fed into a large language model. And this process of learning or training a large language model is called pre-training. We've discussed some other ideas as well. So pre-training is the building or training of a large language model. ठीक है? So what does a large language learns? So it basically learns based on the data that you have used to train it. And since the data is quite huge, it can learn many things. So, for example, it can learn the knowledge of the world. So, we actually discussed these in the last lecture as well. But in the context of large language model, this is just increased even more. For example, large language models can solve mathematical problems. So, for example, if you ask what is the square root of 16, for example, it will give you 4, for example. So how does it does that? How it basically learns the mapping from square root of 16 to the word 4 from large amounts of data. So it doesn't do any computation as such like a calculator does it. Okay? So all of this is possible because of training on large amounts of data where it has probably seen such mappings and also it has learned to generalize from those mappings. So if you give large amounts of data to a machine learner, it will learn to generalize. So world knowledge like who is the author of a particular book, what is the capital of a city, who is the president of a particular country, and then of course reasoning knowledge like if uh, so for example if the room is dark, would I be able to see something? So it can also give answers to that. So this is reasoning using, and of course all of this, the basic framework is the same. You give it input. So if the room is dark, would I be able to see something? Let's say you ask this to the language model. It will then reply by reasoning at your input text and giving you or generating a text. So facts are also known by the language model from text. It also gets to learn how to reason from text. It also learns basic things like mathematics and so on. So a large language model, as I said before, is usually always a neural network, and there are different architectures of neural networks. We have so far only talked about the feed-forward neural network. A large language model can be built using a feed-forward neural network, but most practical large language models today are based on the transformer. ठीक है? So it generally given a input which is natural text, and the output is the probability distribution over the next word. ठीक है? So a large language model is actually a generative model. So remember, generative AI is a keyword that has become very popular in the last 2, 3 years. Actually, I will argue that was very popular. It had become very popular in 2021, 22, 23. Its popularity is actually going down. Uh, so Gen AI का जो लफ्ज़ है, you might have heard it tons of times, but recently इसका जो है ना, its use is going down. Uh, buzzwords आते हैं इंडस्ट्री में, buzzword चले जाते हैं. It doesn't mean that the underlying technology has changed, and the technology वही है. ठीक है. So input, you can see a figure here. The input is basically a LLM. It could be any neural network, and you are given an input phrase, so long and thanks for, and you want to predict the next word. So the prediction for the next word would be a distribution over all possible words, and there are some words that are high with high probability listed here. So for example, so long and thanks for, it could be the word or it could be thanks for all, and so on. Okay, so it can generate, and of course, this thanks for all would be the one that has the maximum probability. So this is kind of predicting. But whenever we are doing generation, more we will like more diversity, as we will see. So we can do random generation. So here in this case, since we are doing prediction, we will do greedy generation. So this is greedy generation, output the most probable word. When we are doing, we want to generate samples that are more diverse, then you will use other techniques like random sampling or temperature sampling. So random sampling we actually talked about in the last lecture as well. We talk about it today briefly as well as temperature sampling. Okay, any questions? So there are actually three broad architectures for large language models. Uh, okay, the question was, as you're generating the output, is the context also changing? In most cases, yes. So this is what is called as teacher forcing, or you can say auto regressive generation. ठीक है, तो वो हम डिस्कस करेंगे. So there are different frameworks. In most cases, if your model is a decoder, actually it follows from this figure as well, this slide as well. So there are three different models for a large language model. One is a pure encoder model, the other is a pure decoder model, and then we have the encoder decoder model. So the encoder model basically would, so here I'm going to explain it conceptually. We'll see an example later on when we discuss the BERT model. So for example, there are examples shown on this slide. So encoder model may use the BERT and its variations आती हैं. BERT is a bidirectional transformer. ठीक है? So what does this mean? That it takes the entire sequence of your input. It doesn't do auto-regressive output. It takes the entire sequence. पूरा आपके पास जो block है input का, it takes at once. And based on that, it generates usually a middle word, but it can also generate the next word or a representation for the entire block. So this is an encoder. So BERT and its variations are of this type. And then the most common architecture is the decoder model. तो इसमें आपके पास सारे जो recent famous names हैं वो आ रहे हैं. GPT है, llama है, Cloud है, and so on. All of these are decoder models. So what is a decoder model? Decoder model is an auto-regressive model. उसके पास sentence word one by one आता है, and based on the context that it has seen so far, it generates the next word. ठीक है? So once it has generated the next word, you can add it to the context. So that is possible. ठीक है? या जब हम ट्रेन कर रहे होते हैं उसको, हम टीचर फोर्सिंग एक कंसेप्ट है वो यूज करते हैं, वो आगे हम डिस्कस करेंगे. So in other words, decoder essentially takes the input and, and reads the input one by one from left to right, autoregressive, and generates the next word. So this is a decoder, and most of the models are of this type. And the third type is encoder decoder, मीनिंग दैट कि पहला encoder पूरा ब्लॉक आपका रीड कर लेता है, पूरा ब्लॉक रीड कर लेता है, उसकी रिप्रेजेंटेशन बना लेता है, एंड देन इट डज द जनरेशन एज ए डिकोडर. तो मतलब दो ब्लॉक्स होते हैं, एक encoder का ब्लॉक होता है, डिकोडर का ब्लॉक होता है. तो इसमें जो कॉमन मॉडल है वो T5 है, टेक्स्ट टू टेक्स्ट ट्रांसफॉर्मर. T5, there are five T's there, so that's why it's called T5. ठीक है. ठीक है, so let's move on to the next slide. So this is the decoder. It takes an input as a series of tokens and generates one token at a time, one word at a time. So this is also called a left to right causal model or autoregressive model. And as I said, this is the most common model that is popularly known today. GPT and Llama and so on are all decoder models. By the way, a feed-forward neural network, which I will discuss shortly, is also would also be a decoder if you use it as a neuro language model. ठीक है. Let's move on to next slide. So encoders, as I said, इसमें जो most popular example BERT and its variation है, which is bidirectional, and usually we consider the whole block of input as once and give a representation for the whole block, meaning that that representation can be used for, let's say, classification or other things as well, or to make a prediction for any one word that's missing in it, in which case it's called a masked language model, which we'll discuss later on. एक हमने वर्ड मास्क किया हुआ है इनपुट में और उसकी हम प्रिडिक्शन करना चाह रहे हैं. सो इन दिस वे, इन दिस अप्रोच, एक्चुअली आपका कॉन्टेक्स्ट पहले का भी है और बाद का भी है, बीच वाला वर्ड आपको चाहिए. ठीक है. सो encoder models are good at contextual representations, as we will see later on, for words, as well as representation for entire sequences or entire sentences, and uh, and you can use it in a fine-tuning way to use it for other applications as well. ठीक है. So encoder decoder, as the name suggests, has two models. One model is encoder, which reads the entire input and generates a representation, and then the decoder works on that representation in a auto-regressive fashion. मतलब वो सारा input ले लेता है and then it generates one word at a time. ठीक है. So decoder and encoder are encoder पहले and then decoder. So these models are also called sequence to sequence models. So पहले पूरा sequence आपका या input block, it might be a block or it might be a sequence. Usually it's a sequence in text. वो read करता है और फिर दूसरा जो है वो भी एक सीक्वेंस को जनरेट करता है. तो फर्स्ट वन रीड्स द सीक्वेंस, द सेकंड जनरेट्स द सीक्वेंस. सो दीज आर समटाइम्स आल्सो कॉल्ड सीक्वेंस टू सीक्वेंस मॉडल्स. तो इस तरह के मॉडल्स आर वेरी नेचुरली suited to applications in which you do generation based on some input text which is kind of much larger. So for example, आपने समराइजेशन करनी है, आप पूरा पहले encoder को पूरा समरी दे दें, पूरा डॉक्यूमेंट दे देंगे, और सेकंड जो आपका डिकोडर है वो उसकी जनरेशन करेगा, समराइज जनरेशन. तो ट्रांसलेशन, समराइजेशन, all of these applications naturally fit into this kind of model. So as I said before, a large language model can be used for almost any task in NLP. So you can use the generation of text even for predicting tasks like classification. Even if the task is not generation specifically, you can use the generation of a word to determine whether it is a classification problem or not. For example, let's say आपके पास मूवी रिव्यूज हैं तो आप मूवी रिव्यूज का पूरा इनपुट दे देंगे एंड देन after that input you ask a question, is this a positive review? It will go into your language model and the language model would output something like yes it is a positive review. तो वो जो yes है it's saying that this is a positive class label even though it has generated a text. While if you know remember जो हमने text classification पहले की थी, हम रिव्यू पूरा देते थे एज ए रिप्रेजेंटेशन और क्लासिफायर बताता था whether it's yes or no either in a from a possible set of labels. Yes कहता था या no कहता था या one या zero whatever labels that you had. It wasn't a text that was generated. So far we will be discussing the decoder only neural language model because we have not studied BERT yet. So BERT is the encoder model and combinations of encoder models can be used for encoder decoder models. So वो हम थोड़ा सा बाद में देखेंगे. So the decoder only model is an auto-regressive model as we saw before. ठीक है? So it takes an input and predicts word one at a time by looking at the context. So your input is usually a piece of text, the starting or the context of the text that you want to generate, and using that as the conditional part, it then generates the next word one word at a time. So this is the idea of a decoder. ठीक है? So we have already talked about this. So many NLP tasks can be posed as generation problems. So give it a sentence if you want to do uh, to give it a proper prompt which is asking about specific thing and then look at what the word comes next. And depending on what word comes next or what sentence has been generated, you can predict uh, sentiment of a particular piece of text. ठीक है, so in this case, since we are doing more or less a predictive job, so we will be generating the output mostly using a greedy approach, meaning that जो maximum probability वाला जो word है, we will generate that. ठीक है, rather than generating it as a random sample over the distribution. So these are some other examples. I will move forward from here. So examples in which you can use a language model for various tasks. And all of this is based on how you prompt the input to the language model. And these are decoders. So these prompts are considered as conditional inputs. And based on this condition, it generates the next word, one at a time. Okay, so let me now discuss the feed-forward neural language model. Uh, so if you recall, we had discussed the feed-forward neural network previously. So which was a neural network with multiple layers, input layer tha, then some hidden layers, and then output layer. And it was primarily used for classification, as we had seen before. So you can use it for text classification. ठीक? And if you recall, जब हमने embeddings पढ़ ली थी, we said that embeddings, of course, are defined for words, and a document typically would have multiple words. So since you are training a neural network, you want to ensure, and of course, a feed-forward neural network has fixed number of inputs. So आपने अब फिर you come into the problem of ensuring that the inputs remain fixed even if your document size is longer or shorter. ठीक है? तो उसमें हमने दो तीन मेथड्स बताए थे, किसी को याद है किस तरह हमने इसको फिक्स करना है इनपुट को गिवन डॉक्यूमेंट्स? Anyone? So we said that you can do truncation, for example, slash padding, meaning that if your document is longer, you simply truncate the remaining words. And this truncation can be based on some selected words. And if your document is smaller, then you simply pad the remaining inputs into the neural network. Okay? And then we said that you can use pooling techniques. And the most common pooling technique is the average. Okay? So a document has, let's say, 100 words. So 100 words के पास vectors हैं आपके पास. उन सारे vectors की आप average ले लें. So you'll get an input that is of the size of one word vector. So let's say आपका word vector के size 300 थे, word embeddings. So after pooling, ठीक है, document representation is also of size 300. ठीक है, तो इसमें size आपका blow up नहीं होता. ठीक है. Of course, there is loss of information, so you have kind of averaged all values for all the words in the document. But it does give decent results for many applications. Okay, so that was text classification. So what about la language modeling? So language modeling में task क्या होता है? You want to predict the next word given the preceding words. So predict next word given preceding words. अब ये preceding words कितने हैं? This is actually your context. So this is the context, and the context you can fix for a particular neural language model. So it could be one word, or it could be two words, it could be 10 words. So if you remember when we talked about the n-gram modeling, we said that using a longer context might be an issue because you can't get good estimates. In a neural language model, we can go to a longer context, uh, primarily due to two reasons. First, of course, is we are using lots of data. So lots of data में आपके पास context मिल जाता है. दूसरा, because we are using a non-linear model, uh, and we are using a neural network, so it can generalize in a better way. ठीक है? So let's say हमने सिर्फ context 3 words का लिया. So let's say 3 word context. So आपका input होगा 3 words का. So you will have basically word 1, word 2, word 3. So this would be input. ठीक है? and output would be word 4 in the training data. This would be output of the network. अब ये word 4 जो output है, this is from a multinomial classification that is done at the output layer. ठीक है? So this is a classification problem. So we find a distribution over the entire vocabulary and we try to ensure that the best probability should come for W4, which is the next word in our sequence. Okay, so we do it in this fashion. Let me show you the slides. उसमें थोड़ा सा pictorially दिखाया हुआ है and then we move on. So these are the slides for the neural network chapter, which we covered partly before as well. अब एक part. So we have already discussed this. So move on to the next slide. Okay. So we are interested in a simple feed-forward neural language model. So we want to predict the next word WT given the context, which can be T minus 1, T minus 2, T minus 3, if you take 3 words as the context. So we, as you can understand, we are using sliding windows over the running text. And since we are using running text, by the way, this is a classification problem. Since we are running text, its label is already available in the running text. So this is called self supervision, as we have already talked before. We don't need any external annotator to label our data. So in this case, this is a pictorial view of the feed-forward neural network in which the context is 3. So you can think of this as a 4-gram language model if you want to relate it to the n-gram language modeling that we studied earlier. So 3 as the context and we want to predict the next word. So inputs आपके पास जो होंगी वो for 3 words होंगी. और if you see in this figure, इसमें एक embedding layer भी दी हुई है इन्होंने. ठीक है? So what is an embedding layer? So embedding layer is basically a layer that contains the embeddings for all the words in the vocabulary. आप input one hot encoding दें, उससे multiply करें तो you will get the relevant embedding for that word. So remember one hot encoding में सिर्फ एक one होता है for the index that is represented at that position, for the index of the word that is represented at that position. और सिमिलरली जो एम्बेडिंग मैट्रिक्स है उसकी भी उसका भी जो पूरा जो जिस इंडेक्स पे वो वर्ड है उसकी सारी एम्बेडिंग उसी पोजीशन पे हो. सो इफ यू मल्टीप्लाई ई विद एक्स यू विल गेट द एम्बेडिंग फॉर दैट पर्टिकुलर एक्स. ठीक है? सो एम्बेडिंग लेयर आप रख सकते हैं आइदर इन दिस वे और यू कैन स्टार्ट विद एम्बेडिंग्स फॉर ईच वर्ड. सो रिमेंबर प्रीवियसली जब हम टेक्स्ट क्लासिफिकेशन शुरू में कर रहे थे वी सेड इट वाज one hot encoding या TF-IDF type of thing, but you can use embeddings. So you can use embedding even for language modeling. So embeddings in this case are static embeddings that you have learned previously using word to vec. हर वर्ड की आपके पास एक embedding आ गई है, you use that as input. So let's say आपके पास 3 words हैं, for example so long and let's say तो सो की एम्बेडिंग होगी, लॉन्ग की एम्बेडिंग होगी और एंड की एम्बेडिंग होगी, तीनों कॉन्कैटिनेट कर देंगे इन ऑर्डर एंड देन इट फेड इनटू द न्यूरल नेटवर्क। एंड द न्यूरल नेटवर्क कैन हैव मल्टीपल हिडन लेयर्स, इसमें शायद एक आपको दिखाई भी है। एंड देन यू हैव एन आउटपुट लेयर विच इज ए क्लासिफिकेशन लेयर, a multi-class classification layer over the entire distribution of words, over the entire set of words in the vocabulary. ठीक है? So if a particular node, of course, there will be as many nodes in the output layer as the number of words in the vocabulary. और जो word predict होगा उसकी जो y होगा, it would be the largest. ठीक है? ठीक है? So if a particular word has the highest probability, so that would be the word that is predicted next. ठीक है? And of course, this probability distribution is computed by taking the softmax over all the outputs of the node. And that outputs, as in our notation previously, we said it by Z. So Z of a is the output of a node before applying sigmoid or softmax or tangent hyperbole. यहाँ slides में आपको U भी नजर आएगा. So I did not change those notation to Z because this is an issue in neural network literature. Different notations use होती हैं, so you should get familiar with them. So even in this book, एक consistent notation use नहीं हो रही, एक ही book में different notations use हो रही, so it sometimes does get a bit confusing. ठीक है? So but I use the symbol Z to denote the output of a node before applying a nonlinear function. तो यहाँ आपने U use किया हुआ है. So neural language models usually work better for various reasons. We have talked about some of these before. Lots of data, for example, nonlinear behavior of the neural architecture that can learn mappings in a much robust way. Uh, and of course, uh, we are using embeddings. Remember, when we do use n-gram language modeling, there was no such thing as embedding. Here we are using embeddings. So embeddings has lots of information about words, how one word relates to another word. So there is an example on this slide that tells you that if you just use the standard n-gram language model, which does not have knowledge of words, it will give you a wrong answer. While if you use a neural language model, it will give you a better answer. ठीक है? So neural language models can use embeddings and determine the similarity between dog and cat to predict the best word for the test set. Okay? So generalization performance is good because of several reasons. Data ज़्यादा है, embedding use कर रहे हैं, neural network की capacity ज़्यादा है, and so on. ठीक है? I think that is pretty much it from this slide. So, so we were discussing large language models, and I gave you an example of how you can use a feed-forward neural network as a language model. ठीक है? So in this case, this is a neuro language model, and we use a sliding window of inputs, and those inputs can be given in terms of embeddings, and then we predict the next word given the context. ठीक है? So it is a classification problem, but using sliding windows. Okay, going back to the previous slides. So we will skip this prompt discussion till later. So let's start from here. So we already know about this. So where do we get the probability for the the word that is predicted at a particular output node? So you take the softmax over all the outputs. Okay. So the outputs in this slide is denoted by logit. Logit भी कह सकते हैं, but I think it's pronounced in a slightly different way. But this is the Z value that we talked about earlier, or the U value as given in this slide. So, so this vector of U is then converted into probability using applying softmax. Okay? And this softmax is a probability for all the words over in the dictionary or the vocabulary, and the one that has the highest probability would be selected if you are doing greedy sampling or if you are doing a prediction. Remember, prediction में हम usually maximum output वाला ही लेते हैं. ठीक है, so you generate a probability over the entire vocabulary. Just a second. So the whole concept of what to generate given the probability that is produced at the output layer of a neural network is called decoding. Okay? So we have already seen two decoding techniques. One is the greedy approach, ठीक है, in which is usually used for prediction. ठीक है, greedy approach में ये होता है कि जो maximum probability होती है वो word हम predict कर देते हैं. We have also seen random sampling over the distribution. We discussed that in the last lecture. इस lecture में भी थोड़ी सी इसकी slides हैं. So in that case, we do not take the one that has the maximum probability, but we use that distribution, whatever that distribution is, to generate one word randomly. So this approach gives you diversifies your output, and it is primarily used for sampling and primarily used for generations of मतलब generations जहां आप करना चाह रहे हैं with greater degree of variety. So remember, if for those who have used these tools, so GPT या उसमें एक temperature parameter भी होता है या एक और कोई parameter होता है that tells you कि आपने uh, you want it to be more flexible in its output or you want it to be more fixed in its output. So this is where they change it. कि वो सैम्पलिंग पे वो अपनी वेरिएशंस करते हैं कि सैम्पलिंग में वो ग्रीडी बेस्ट आंसर दे रहा है या आपको फ्लेक्सिबिलिटी दे रहा है. And flexibility is usually done, as I said, in a random approach, either pure randomly or using temperature sampling. So we have already talked about greedy decoding. So the word that is the most probable is outputted. Okay, so it generates the most probable word. It is locally optimal, but it may not be optimal if you are generating a whole sequence of words. Okay. So जो भी maximum probability है वो आप generate कर देंगे. So this is an example for greedy decoding. So all has the highest probability in the output. Okay. So this is the input is so long and thanks for. So we want to generate the next word. So all has the highest probability and it will be chosen because we are using the greedy approach. So in general, whenever you are using Gen AI or generative AI or generative NLP, we typically don't use greedy uh, decoding. We only use greedy decoding for predictive AI. ठीक है. So by definition, we are trying to get a very predictable word, the best word for a something. So there is less variation, there is less variety in the output. So random sampling is the more common approach, and we have already seen this when we discuss n-gram language modeling. वही चीज़ है यहाँ भी. So you have a distribution over the entire set of words in the vocabulary. You generate a random word according to that distribution. ठीक है. अकॉर्डिंग टू दैट डिस्ट्रीब्यूशन का मतलब क्या है कि एक वर्ड जो बहुत हाई प्रोबेबिलिटी डिस्ट्रीब्यूशन में है, तो देर इज ए हायर चांस के वो सेलेक्ट हो जाएगा इन रैंडम सिलेक्शन. ठीक है. इट्स नॉट सेइंग कि वो हमेशा होगा. रैंडमली उसकी प्रोबेबिलिटी की सिलेक्शन होने की ज्यादा होगी. ठीक है. So this is basically the pictorial view of this. The softmax layer at the output converts the outputs that you get in terms of Z or Z or U into probability distribution. That probability distribution is then sampled to get the best word or the next word that is according to this sampling. Okay, so for example, all की probability 0.44 and then other words as well 0.33 and so on. So ये probability है और ये distribution use करके आपने फिर generate करना word. So we talked about this last time as well, so I think you should remember from there. I will skip this slide. So random sampling also has issues, and the reason for this is that the distribution that you typically get for the predicted word is the long tail distribution, meaning that आप उसको plot करेंगे तो plot उसका जो है ना वो कुछ words होंगे जिनकी probability high होगी and there will be lots of words जिनकी probability बहुत low होगी. ठीक है. So the probability space that those lots of words pick up, even though they have low probability, in your line from 0 to 1 would be quite large. उसमें से कोई भी word आ सकता है, and those words won't have any as such relation among themselves, so they will look like more or less random words. So so that gives a lot of variety and variation, and the sentence may not look like a proper sentence. Because so we need to control that. We need to control that in some way. And the most common way of controlling this is using temperature sampling, as we will see in the next slide. Okay? So long tail distribution hai, but since there are tons of words uh, with low probability, they do take up a significant chunk of your unit probabilities range from 0 to 1. And between those words, there may not be a lot of uh, correlation and dependence, and you might get sentences that look more or less like random. So we want to emphasize high probability words, but also we want to maintain some diversity. Okay? So these are the two things that we need to balance. So the more common approach that is used, especially for generative AI, is temperature sampling. So the idea is that we reshape the probability distribution. So if the probability distribution is like this, we use a scalar parameter tau to reshape it. Okay? So using this tau, we can increase the probability of high probability tokens and decrease the probability of low probability tokens even further so that they don't get selected. Okay? And of course, you can vary this tau to ensure that you kind of make sure कि आपको almost uniform distribution आ गई है. So all words से आप equally likely select कर सकते हैं. So in other words, ये एक parameter है. You can call this a hyperparameter. You can tweak this, and by tweaking this, you can change the generation of your large language model. So I think this parameter is available for the GPTs and llamas that are out there. तो आप इसको tweak करके इसको खेल सकते हैं इसके साथ. So how does this work? So you divide the output Z or U as is mentioned in this slide by this parameter tau. And the tau is a parameter that ranges from 0 to above. It's not negative, it's 0 and above. If it is 1, obviously Z divided by 1 means that there is no change. So जो भी output था वही output आपके पास रहेगी, and you get the random sampling approach that we saw earlier. ठीक है? But if tau is not 1, then you can somehow change the distribution. So if let's say tau is less than 1, let's say 0.5 है, तो remember z में जो values होंगी उसको आप फिर divide कर रहे होंगे 0.5 से, so they will kind of increase. But z में जो values बहुत छोटी होंगी, ठीक है, तो by the way those will increase to a greater extent as compared to those values that are smaller. They will increase to a lesser extent. ठीक है, because those values are smaller. अब इसके ऊपर जब आप बाद में सॉफ्ट मैक्स लगाएंगे तो आपकी जो पहले हाई प्रोबेबिलिटी वैल्यूज थी वो और हाई हो जाएंगी और जो कम प्रोबेबिलिटी वैल्यूज हैं और कम हो जाएंगी. ठीक है, सो आपकी शेप चेंज हो जाती है. ठीक है, सो आई थिंक नेक्स्ट स्लाइड में एक डायग्राम दी हुई है, लेट्स लुक एट दैट. So as you can see in this figure, so depending on the tau that is applied on the output Z or U, you can change the distribution or sharpness of the distribution that you get from of the probabilities over the words. ठीक है, if tau is less than 1, you kind of, let's say आपकी original distribution let's say यूं थी, so let's say यूं मैं कहता हूँ यूं थी, तो वो थोड़ी सी ज़्यादा पीक हो जाएगी यूं करके. if less than 1, if it is greater than 1, it kind of smooths out. ठीक है, स्मूथ आउट होती जाएगी. इनफैक्ट आप बहुत हाई कर लेंगे ऑलमोस्ट यूनिफॉर्म प्रोबेबिलिटी हो जाएगी, पीक सारे निकल जाएंगे. ठीक है, लेस देन 1 होगी तो पीक्स ज़्यादा हाईलाइट हो जाएंगे डिस्ट्रीब्यूशन में. ठीक है, सो दिस इज एक्सप्लेनिंग व्हाट आई जस्ट मेंशन. सो इफ इट इज 1 तो चेंज नहीं होगा, लेस देन 1 है तो जो पीक्स पहले थी वो ज़्यादा पीक्ड हो जाएगी, एंड इफ इट इज ग्रेटर देन 1 तो वो स्मूथिंग फैक्टर आ जाता है उसमें. So this is the figure that actually shows you those distributions for various taus. ठीक है, ठीक है। सो आपके पास जेड की वैल्यूज दी हुई हैं कुछ उन्होंने, एंड देन फिर टाउ को आपको इंक्रीज कर रहे हैं एंड अप टिल मैक्सिमम ऑफ 10। 10 के लिए यू नोटिस कि आपका ऑलमोस्ट यूनिफॉर्म डिस्ट्रीब्यूशन हो रही, स्मूथ आउट हो गया। एंड व्हेन टाउ इज स्मॉलर then your distribution is much more peaked. So now you will be sampling according to this distribution after making the change. You are not sampling according to the original distribution. In other words, you are changing the distribution. शेप कोशिश कर रहे हैं वही रखें, बट उनके पीक्स एंड लोज आप चेंज कर रहे हैं. So in a way, you can argue that this is changing what you have learned from the data, right? In a somewhat arbitrary way. So that is true. But as I said, this is a hyperparameter. You can tune this according to your needs. So you can learn this parameter according to your needs as well, in addition to learning from data. और ये आपको एक पैरामीटर मिलता है फॉर मोस्ट जनरेटिव एआई मॉडल्स दैट आर आउट देयर. तो यू कैन ट्वीक दिस मॉडल टू इंश्योर कि आपको ज़्यादा वैरायटी आउटपुट हो. एंड इफ़ यू टेक टाउ टू बी लार्जर और स्मॉलर करेंगे तो लेस वैरायटी एंड मोर फैक्चुअली करेक्ट. Of course, the idea comes from thermodynamics, so I'll skip this slide. So these three stages of training of a large language model, we will discuss this in more detail later on as well. ठीक है, तो एक तो प्री ट्रेनिंग है और एक इंस्ट्रक्शन ट्यूनिंग है एंड देन अलाइनमेंट है. तो प्रेफरेंस अलाइनमेंट एंड इंस्ट्रक्शन ट्यूनिंग एंड प्री ट्रेनिंग. ठीक है. सो we will be discussing these later on as well. So pre-training essentially क्या होता है, large amounts of data जो आपके पास है, in a self-supervised fashion you train the model. जो मैंने अभी दिखाया था for feed forward neural network. आप context लें और predict the next word, train the data, train the model on that data so that it learns to predict the next word given the previous words. So this is pre-training and you do it on lots of data. Instruction tuning is basically that you tune the output based on some prompts that you give. So जब हम prompts engineering का आगे discuss करेंगे वो हम आगे देखेंगे. And preference alignment is more subtle adjustment of the large language model to ensure that some things are highlighted and others are not highlighted. For example, large language models may output private information or large language models may output for example harmful information. So उसको ठीक करने के लिए through reinforcement learning we do reinforcement preference alignment. So primarily we'll be focusing on pre-training, of course not focusing in the sense कि हम इसको actual करेंगे, people have already done this, but इस slide में we will talk about pre-training and later on we will briefly talk about instruction tuning and preference alignment. Okay, so this is the idea. You train it on lots of data, and within the lots of data, you already have the supervision signal. We are trying to predict the next word given the previous word. So remember, we are focusing on a decoder model, auto-regressive large language model. ठीक है. The next data word already available आपके पास. So once you have learned that model, then you can use it for new tasks, and that new task could be obviously, when we use a large language model, we are using it for generation, but that generation can be used for prediction problems as well, as we saw before. So we have already talked about this. You know about this. ठीक है. So we are giving the input text, we're giving also the correct next text word, and then using gradient descent and backpropagation to update the model. So the loss function remains the same as we saw before. It's a classification problem, so cross entropy loss use होता है, उसको आप minimize करते हैं. So we have already talked about this. Okay, teacher forcing. So while you're training the data, ठीक है? So while you're training the data, what happens is आपने लेट्स से जो फीड फॉरवर्ड का हमने देखा था, हमने W1 W2 W3 दिया था और W4 हमने प्रिडिक्ट किया था. W4 वाज एक्चुअल वर्ड इन द ट्रेनिंग डेटा. ठीक है. बट इट इज़ वेरी लाइकली पॉसिबल कि जब आप ट्रेन कर रहे हैं तो वो W4 इसने प्रिडिक्ट नहीं किया, कोई और वर्ड प्रिडिक्ट कर दिया. लेट्स से W4 वाज द वर्ड ऑल. ऑल इसने प्रिडिक्ट नहीं किया. द वन विद द हाईएस्ट प्रोबेबिलिटी वाज लेट्स से डी. ठीक है. सो ऑब्वियसली दैट वुड बी एन एरर एट द आउटपुट लेयर. वो एरर ऑफ कोर्स हम उसको यूज करेंगे अपने मॉडल को अपडेट करने के लिए. बट व्हाट हैपेंस इज कि जब आप स्लाइडिंग विंडो आगे लेके जाते हैं, we don't use that actual word that was predicted in the sliding window. We go back and use all there. So in other words, the teacher, which is our training data, is not using the actual predicted word, but is using the true word from the data. This is called teacher forcing, and this is part of generation. It is part of training. Okay, so I hope you understood this concept. So it's a straightforward concept, but it has a name that is quite frequently used in NLP. So teacher forcing. So इस नाम से ये कहा जाता है. So again to reiterate, आपके पास जो भी predicted word, जो correct predicted word था, let's say all, but आपका मॉडल जो highest probability दे रहा है, D दे रहा है. तो आपने अगले जब आप विंडो आगे मूव करेंगे, आप all यूज करेंगे, D नहीं यूज करेंगे. So that does seems to be intuitively okay, of course in training, but sometimes and most times in even generation हम यही करेंगे. So we will see that maybe later on as well. So this is a figure describes the entire process of feed forward and backward propagation of a neural network. So ये I think पिक्टोरियली दिखा रहा है जो मैंने अभी पहले बता दिया. इनपुट आपके पास है वही सो लॉन्ग एंड थैंक्स फॉर. आउटपुट आपने ऑल करना है, बट ऑल लेट्स से नहीं होता, एरर आएगा, एरर बैक प्रोपेगेट होगा. बट नेक्स्ट जब आप विंडो आगे मूव करेंगे उसमें long and thanks for all आप यूज करेंगे, not the actual word that is used. So now coming to the data that is used to train large language models. So obviously, as we have mentioned this previously many times, we need lots of data to get good generalization performance. So there are various uh, data sets out there. One of the earliest was the common crawl, and it's still out there available. This is the crawl of the entire web space. तो मीनिंग दैट जितने भी वेब पेजेस हैं सब कुछ है उसका, ये डंप है. So 156 billion English tokens. So it's a huge corpus. ठीक है. But there are other corpora available out there, and there are also proprietary corpora that you don't have already out there in the public. So this is another corpus that is collection of the web, the books, the articles, conversation, dialogue, and so on. Again, a massive data. ठीक है. So obviously, while you're training a large language model, you need to filter the data for quality and also to ensure that you don't learn harmful things in the large language model. So that, by the way, is also a part of our discussion. आज शायद वहाँ तक ना पहुँचे. That's the end of this section. And obviously, quality is subjective and difficult to monitor. ठीक है? Especially when we are dealing with huge amounts of data. So whenever you crawl from the web, you also have junk information like uh, data that is repeated multiple times across websites, like headers and footers and stuff like that. And also you may have code. Of course, we learn over code as well. वो भी available हो सकता है and so on. But again, quality maintain करनी है again in some context. तो you need to make sure कि क्या चीज़ उसके अंदर जा रही है LLM के अंदर और क्या नहीं जा रही. So safety is also important. And again, there is no hard and fast, uh, well accepted way of ensuring that LLMs are safe. ठीक है. सो बायसेस भी आ सकते हैं उसके अंदर और चीज़ें भी आ सकती हैं. टॉक्सिसिटी फॉर एग्जांपल आ सकती है. इफ़ यू बेसिकली learn your large language model over social media content, large language model will learn all the vernacular and hate and offensive speech that is prevalent on social media. ठीक है. And then there are also non unintended harms. For example, let's say कोई ऐसी language है that people tend to associate with uh, some negative sentiments, और वो नेगेटिव सेंटिमेंट्स के लिए ज़्यादा यूज़ हो रही होती है तो योर LLM would tend to bias towards that. तो यहाँ ये लास्ट सेंटेंस में ये एग्जांपल दी हुई है. अफ्रीकन लैंग्वेजेस कोई ऐसी हैं जो अफ्रीकन एक्सेंट टू इंग्लिश, इट माइट इम्प्लाई कि ये is not correct or the information that is in them is not relevant or of or of high authority. So yeah, again, these implicit indicators would be something that your LLM would learn. So you need to be careful about that. Even if let's say वो कोई proper document था, but since it is written in that particular language, वो उसको उसी context में देखेगा कि this is not a authentic piece of information. ठीक है. So again, there are harms associated with just blindly copying data and uh, using it in your LLM. By the way, this is a major issue that has not been solved as well. So आप LLM में अब सारी बुक्स भी जा रही हैं. बुक्स यूजली आर कॉपीराइटेड. आप LLM को आप प्रॉम्प्ट कर सकते हैं बुक की एक पूरा पेज या एक मेजर पोर्शन उसका रिप्रोड्यूस करवा सकते हैं. सो वेयर इज द कॉपीराइट फॉर दैट बुक. So these are issues that are still unsolved. कॉपीराइट का इशू है, अदर लीगल इश्यूज है, प्राइवेसीज के इश्यूज हैं, सिक्योरिटी के इश्यूज हैं. सो ऑल ऑफ दीज आर हार्म्स दैट आर एसोसिएटेड विद लार्ज लैंग्वेज मॉडल्स. अच्छा, फाइन ट्यूनिंग आ गया ये. ओके. 310. अच्छा. सो वी आर एक्चुअली फाइन ट्यूनिंग भी अब ये थोड़ा सा बाद में डिस्कस करेंगे. द लास्ट सेक्शन इज एक्चुअली वो हार्म वाला है, वो मैं क्विकली डिस्कस कर लेता हूँ. Of course, evaluating of large language models, we have already discussed this before. Perplexity और उसकी variations ही use होती हैं to intrinsically evaluate language models. Of course, ये slide थोड़ी सी है relevant, ये मैं discuss कर लेता हूँ. So of course, we evaluate large language models using perplexity, which is intrinsic evaluation of the performance of a large language model. ठीक है? But there are other issues associated with large language models. You already know this from media. So what is the size of a large language model? Number of parameters. ठीक है? So usually billions and sometimes even trillions of parameters need to be updated for a large language model. And then of course, the issue of using power, energy to train them. ठीक है? That's a major issue. Uh, उसमें बाय द वे पावर भी के साथ कूलिंग का भी इशू है, वाटर का यूज भी है, सो दैट्स आल्सो एन इशू. सो देन अदर इश्यूज के कितना वो हार्मफुल है लार्ज लैंग्वेज मॉडल, कितना फेयर है, कितने कम बायसेस हैं, सो यू कैन यूज ऑल ऑफ दीज अदर फैक्टर्स टू इवैल्यूएट लार्ज लैंग्वेज मॉडल्स एज वेल. ठीक है. And of course, one other way, from a purely NLP perspective, large language models are evaluated on benchmarks of various NLP tasks. So benchmark जैसे glue है, GLUE है, for example, it's a benchmark which contains various tasks. Summarization है, translation है, other है, उनके standard data sets हैं, standard outputs हैं. So you might have noticed in the literature, हम जैसे कहते हैं GPT-4 की performance इस benchmark पे ये थी, GPT-5 की improve हो गई है. So how do they tell us? Because they have used a benchmark data set. So these benchmark data sets are available out there. ठीक है. सो ये लास्ट फ्यू स्लाइड्स हैं ऑन हार्म ऑफ लार्ज लैंग्वेज मॉडल. मेरे ख्याल से ये ब्रीफली पे नेक्स्ट क्लास में मैं कर लूँगा, थोड़ा सा ओवरलैप हो जाएगा इस क्लास के साथ. एंड देन वी विल मूव ऑन टू रिकरेंट न्यूरल नेटवर्क्स एंड ट्रांसफॉर्मर्स. सो दैट वुड बी मोर मैथमेटिकल, तो वो हम डिस्कस करेंगे नेक्स्ट. ठीक है. सो आई थिंक दैट इज ऑल फॉर टुडे. आर देयर एनी क्वेश्चंस? एनी क्वेश्चंस? सो एनी क्वेश्चंस? ओके, बाय द वे, लास्ट टाइम जैसे बताया था कि क्विज होगा मंडे को इंशाल्लाह. तो you have a quiz that is covering all material from the preceding quiz. जो preceding quiz में नहीं आया था उस लेक्चर से लेके आज के लेक्चर तक. So it is a bit more content. So please do spend time revising the content. Quiz उतना ही 15-20 मिनट तक होगा. And I'm planning to take it at the start of class. Uh, तो ये स्लैक पे आपको 100% कंफर्म भी कर देंगे. तो स्टार्ट ऑफ क्लास मैं लेना चाह रहा हूँ एंड देन वी स्टार्ट आवर लेक्चर ऑनलाइन एट 2 to 5. ठीक है. So any comment on that? बाय द वे, ये जो लार्ज लैंग्वेज मॉडल वाला चैप्टर है, ये स्लाइड्स भी हैं, अपलोड कर दूंगा. और इसका चैप्टर 7 है टेक्स्ट बुक का. All right, so I think that's all from my side.